On the southern tip of Texas, where the Gulf of Mexico meets the Rio Grande, Starbase is not just a facility. It's a groundbreaking hub that's changing the future of spaceflight as we know it. This is SpaceX's rocket shipyard, a place where the largest and most powerful rocket ever built, Starship, comes to life, ready to redefine our journey to the stars. But Starship needs a powerful partner to reach its full potential, the Super Heavy booster. Super Heavy is the first stage, a towering 71-meter column of stainless steel, meticulously engineered to launch Starship skyward before returning to land with precision. It's powered by an impressive array of 33 Raptor engines, burning liquid methane and oxygen, producing more than twice the thrust of the legendary Saturn V, making it a true powerhouse. Super Heavy's job is short and intense. Just a few minutes to push Starship toward orbit, then it heads back to Earth, ready for its next mission. The real innovation? Reusability. Like an airliner, Super Heavy is designed to fly, land, and launch again quickly, revolutionizing the economics of space travel. This slashes the cost of space access, making ambitious missions possible, from lunar landings to Mars colonization. At Starbase, rockets are built and tested out in the open, with a relentless pace of construction and iteration, pushing the boundaries of what's possible. Engineers learn fast. Every test, success or failure, feeds into the next design, ensuring rapid progress and innovation. The process is simple yet effective. Build, test, fly, improve, and repeat. That's why Super Heavy is already getting a major upgrade, even as early versions have flown, showcasing SpaceX's commitment to continuous improvement. The goal is clear: make each booster more robust, reliable, and easier to reuse, setting new standards in rocketry. Starbase is a living laboratory, where the future of rocketry is being forged in real time, with every launch contributing to a legacy of innovation. The journey is just beginning, and every launch brings new lessons, paving the way for even greater achievements. SpaceX's approach is to evolve quickly, not wait for perfection, embracing a philosophy of rapid iteration and learning. Each new Super Heavy is a leap forward, not just a repeat, embodying the spirit of progress and exploration. The scale, ambition, and speed at Starbase are unlike anything before, setting a new benchmark for the industry. This is where the next era of space exploration is being built, one booster at a time, with each component playing a crucial role. The Super Heavy story is one of constant reinvention, a testament to human ingenuity and determination. And the best is yet to come, as we stand on the brink of a new frontier in space exploration. SpaceX's philosophy is simple: iterate fast and never stop improving. They don't wait for perfect blueprints or flawless designs. They build, test, and learn from every attempt, pushing boundaries with each cycle. Every flight, whether it ends in triumph or failure, reveals new ways to improve and innovate. For Super Heavy, upgrades aren't just helpful, they're absolutely essential for survival and progress. 33 engines firing together create extreme forces, vibrations, and intense heat that test every component to its limits. The booster must survive the violence of launch, the searing heat of re-entry, and then stick a pinpoint landing back at Starbase. Any flaw, no matter how small, can mean losing the entire vehicle, so making it tougher, more reliable, and easier to reuse is always the top priority. The ultimate goal: make Super Heavy as reliable and routine as a commercial jetliner, flying frequently and safely. Early flights prove the basics and test the core systems. Later flights refine the design for rapid turnaround and operational efficiency. Upgrades focus on stronger structures, more efficient engines, and simpler, more robust systems that can handle repeated use. Each change is driven by real-world data from test flights, not just theory or simulations. SpaceX used this relentless approach with Falcon 9. Constant upgrades turned it into a rocket that now dominates the global market. Now they're applying the same winning formula to Super Heavy, but on a much bigger, more ambitious scale than ever before. Every makeover, every tweak is progress. Not a setback, but a step closer to the future of spaceflight. This relentless drive for improvement is what truly sets SpaceX apart from the rest of the industry. If Super Heavy already flies, why change it? Early boosters were prototypes, proof that a giant, multi-engine rocket could work. But flying once isn't enough. True reusability demands more. The first designs were complex, with miles of wiring and plumbing, hard to inspect and refurbish. The new design streamlines everything, integrating systems and reducing parts. Simpler means stronger, lighter, and faster to build. Every kilogram saved boosts payload capacity. Lighter, more efficient structures mean more cargo to orbit. Upgrades also prepare for the future, handling the stresses of hot staging and repeated flights. Lessons from test flights shape every improvement. The goal, a robust, resilient booster ready for routine missions. Each change is about making Super Heavy easier to build, fly, and reuse. That's how you turn a prototype into a workhorse. The biggest upgrade? A new tank design. Old boosters had separate domes and a connecting skirt between tanks. The new version uses a single integrated common dome, simpler, lighter, and stronger. This cuts weight and speeds up manufacturing. Less mass means better performance and more payload. The forward section is also redesigned, cleaner, stronger, and better at handling hot staging. Plumbing and wiring are now more accessible and reliable. Even the systems for filling, draining, and controlling the booster are improved. Hydraulic systems are upgraded for better grid fin control. The catch and stack system is evolving with reinforced lift points built into the structure. Every tweak adds up to a more mature, reusable rocket. These changes aren't just upgrades, they're steps toward routine airline-like operations. Super Heavy is becoming a true next-generation launch vehicle. Let's take a closer look at the evolution, old Super Heavy versus the new. The differences are striking, and each change tells a story of progress. Early boosters, like Booster 9, were intricate webs of rings, welds, and separate tanks. Pioneers built to gather data and push boundaries. These first versions were experimental, designed to learn what worked and what didn't. The new boosters, such as Booster 13, are sleeker, more integrated, and visually streamlined. Their exteriors are smooth, with far fewer visible welds. The introduction of a common dome means fewer welds, less weight, and greater structural strength. This innovation simplifies construction and boosts performance. The forward section is now purpose-built for hot staging, not just an add-on. This allows for more efficient stage separation and improved mission flexibility. Internally, the new design replaces dense networks of pipes and hydraulics with integrated, often electric systems. This shift marks a major leap in reliability and maintainability. By cutting complexity, refurbishment becomes faster and more predictable, reducing turnaround time between flights. Electrification replaces leaky hydraulics for engine and grid fin control, making the systems more robust and easier to maintain. Fewer parts mean fewer things to go wrong, which translates to higher reliability and less time spent troubleshooting. The result is a booster that's not only easier to build and test, but also much quicker to turn around for the next flight, supporting rapid launch cadence. SpaceX is moving from make it work to make it routine, aiming for launches to become as regular as clockwork. Each new booster represents a leap in reliability and efficiency, building on lessons learned from every previous flight. The pace of evolution is rapid, and it's just getting started. Every iteration brings new advancements and sets the stage for what's next. This is how you build a rocket for the future, by constantly improving, learning, and never settling for good enough. The hot staging ring is a game changer for Starship launches. It's a vented ring atop Super Heavy, enabling the upper stage to ignite before separation. Hot staging keeps momentum, boosting payload by up to 10%. The ring's vents let exhaust escape, preventing pressure buildup that could destroy both stages. It must be strong enough to support Starship and withstand the heat of ignition. The top of Super Heavy is heavily shielded for protection. Recent upgrades focus on making hot staging routine and reliable. The forward section is now built to handle repeated thermal and physical stress. SpaceX is refining the ring's materials and vent patterns for durability. Successful hot staging in recent flights proved the concept. Now, the goal is to perfect it for every launch. This innovation is key to Starship's performance edge. Hot staging is now central to the system's future. Starbase isn't a typical rocket factory, it's a rocket shipyard. Boosters are welded together outdoors, in a sprawling, fast-paced campus. SpaceX's vertical production line lets them build and stack rockets in months, not years. Speed is crucial. Lessons from one flight are built into the next booster almost immediately. Testing is just as rapid cryogenic proof tests, then static fires with all 33 engines. Failures aren't disasters, they're data. A failed engine or ruptured tank teaches engineers how to improve. Old prototypes are scrapped as new ones roll out. This unsentimental, real-world approach accelerates progress. It's how SpaceX pushes rocketry forward at breakneck speed. Super Heavy's upgrades are about more than rockets. They're about making life multi-planetary. Every improvement brings Elon Musk's vision of a Mars city closer. Reliability and reusability are essential for Moon and Mars missions. The new design aims for airliner-like dependability and rapid turnaround. Weight savings mean more cargo, fuel, or equipment per launch. Fewer tanker flights are needed to refuel Starship in orbit, simplifying Mars logistics. Lowering the cost per kilogram to orbit unlocks new possibilities, lunar bases, space stations, and more. Super Heavy's evolution is the key to affordable, frequent space travel. Each upgrade is a step toward building a future beyond Earth. The work at Starbase is laying the foundation for humanity's next giant leap. The mega makeover is about unlocking the solar system. What's next for Super Heavy? More flights, more data, more upgrades. The immediate goal: launch, land, and catch the booster with the launch tower's giant arms. Success here means true operational reusability, quick turnaround between flights. Each mission tests new systems and gathers data for further refinements. The Starship upper stage will also be pushed to deploy satellites and practice in-orbit refueling. Frequent, reliable launches are the foundation for Moon and Mars missions. Super Heavy is set to become the workhorse of a new space era. Multiple launch pads and a fleet of boosters will support NASA's Artemis and future Mars missions. The upgrades we see now are just the beginning. Super Heavy's transformation is forging the key to our future in space.